So what I did is I went into my Google Mail, and up at the top you'll see some possibilities, and one of them is Drive, and you click open Drive and you can create different documents. And so I created a spreadsheet, and here is our table from our problem. And keep in mind what we have here is a system of equations. And you might think, well, you could solve this using chapter 3 techniques, find the intersection, uh, by elimination or by substitution, solve the system of equations. It's not quite that easy because uh, we don't have addition between these, we have multiplication between these. And so, but the idea is the same. We are looking for the intersection of these two equations, so to speak, and once we find the intersection, we have found the solution. And so if I run some experiments with different values of t, there's going to be a certain t, hopefully, where I'll get the same r, and I'll have effect the same r and the same t being solutions for both equations, and that would be the intersection. So that's the mathematical idea going on behind running this experiment. The other value of the experiment is I get a feel for the problem. I'm going to play with different values of time. And I decided, okay, well, suppose the planes are in the air, the plane A is in the air for 4 hours, t is equal to 4. Then plane B is in the air for 1 hour. So I had to choose a number greater than 3, and 4 was the first convenient number. And notice that we have distance is equal to rate times time. Distance is equal to rate times time. And if we know the distance and we know the time, we can find the rate. Simply, well, generically, we divide both sides by t, and we can solve for r. And so distance divided by time, that's what's going on with this whole column right here. I'm taking 6,300 and I'm dividing it by 4 to get this, to get a rate. So when a plane goes 6,300 kilometers in 4 hours, it is going 1,575 kilometers per hour. When it goes 6,300 kilometers in 5 hours, it's going slower, and it's going 1,260 kilometers per hour. And so on, all the way down to 19 hours. And I could have taken it on farther, but I suspect the answer is someplace in this range. And now, we can do the same thing for plane B. And this is where, when I played with numbers, the idea of how to solve this one algebraically came to me. Again, we have this situation. We are going to solve for r by taking d divided by t. But notice here that in the case of plane B, our distance is 4,500 kilometers. Our time is t minus 3, and our rate is r plus 50. So we need to subtract 50 from both sides to get r. And so our r is really equal to 4,500 divided by t minus 3 minus 50. And so that's what I needed to figure the calculations behind this number right here. And let me show you one of the nice things about spreadsheets is once you get the formula in there, here's the formula. Once you get it in there, 4,500 divided by whatever over here, minus 3, minus 50. Once you get it in there, you can simply select the cell and drag to duplicate everything going down. So I only have to enter it once. And lo and behold, look right here. At 9 hours, I get the same rate. R is equal to 700. It's the only situation. And so when t is equal to 9, r is equal to 700, and we in fact have an intersection. And so the answer is r is equal to 700, and plane B is 700 plus 50. So the rate of plane A is 700 kilometers per hour, and the rate of plane B is 750 kilometers per hour. All of this helped me solve the original problem. Let's go back to that and finish this off.